Hi everyone, I hope you are doing good. So today we will discuss a new question here, and in this session we will discuss first question. We will try multiple use cases, and then we will discuss the algorithm solution, and then we will implement that solution into the C++ code, and there we will run the multiple use cases. So first let's understand the question here. So the question is given an array having both positive and negative integers, and the task is to compute the length of the largest subarray with sum. So basically there will be an array. So for example here we have given one array. So let me write it here. So we have one array that is 15, 10 and 23. So this is the given array, and we have to compute the largest subarray. There will be multiple subarrays here, right? But we have to compute the largest subarray with sum is 0, right? So for example here, see here we have this subarray 2 and 2. This is one subarray, right? Minus 2 and 2, and here length is 2 only. It is making sum to 0, right? And then other subarray is this one, correct? Here minus 8, 1 and 7. This is also making 2 sum 0, right? Minus 8, 1 and 7. And here length is 3. Can we make another array? So if we look at this given input, then see this is also making some, and these are the adjacent arrays, subarrays basically, right? So we can merge this complete array into one subarray, right? And this is also making 0, right? So the another array we found is minus 2, 2, minus 8, 1 and 7. So this subarray is also making sum to 0, right? And here length is 5. So our output should be 5 in this case, right? So this is the question. I hope you understood it. We have to find the largest subarray, and the sum should be 0 of that subarray, and the length we have to tell. Basically, think about the solution algorithm, and then if you find any different algorithm other than whatever we will discuss, then comment below the video so that we also get to know about that solution. So let's discuss about the solution first. So here there would be multiple solutions. So what we will discuss here. So first we will try to use the brute force. That would be order of n cube. Then we will optimize this solution here. So this would be brute force, and then we will optimize this, and we will try to optimize to n square here. This solution we will discuss, and finally we will use that prefix sum algorithm, and there we will make this solution into the order of n time complexity with the order of n space complexity. So this would be our optimized solution, and these three solutions we are going to discuss in this session, and then we will implement all these algorithms into the C++ code, and then we will run the use cases. So let's discuss about the first solution here, brute force one. So what we are going to do in brute force, what we can do here. So you can see each element is kind of one subarray, right? So we will try all the subarrays here, all the possible subarrays here, and then we will compute the basically sum of the all the subarrays, and if the sum is 0, then only we will consider it in the result or in the output, right? And then likewise we will also together we will compute the largest length, and whenever we get any largest subarray with sum 0, then we will update our result. So that would be our brute force one. So let me show you the algorithm here. So this is the brute force approach. Here what I am doing, here we are taking one result value, right? So here in result value what we will do, in result value we will store the result, and here the first loop, basically this loop is for every length. It will check for the length from one length to the n length array, right? Because each element is a subarray kind of things, correct? And then after that we will make one more for loop here, and this for loop will tell the position of the starting of the subarray, right? So for example, three length subarray. So three length subarray, there would be this is one three length subarray, right? Then this is another three length subarray. So kind of this, and here starting position is 0 index, and then here 1 index. So kind of all the three length subarray it will calculate, right? And here this another inside loop, this one, this is basically calculating the sum of the given subarray, whatever the current subarray. So for that we are basically calculating the sum, and if sum is 0, then we are updating our result. So this is our brute force approach, right? So this is order of n cube. So now we will optimize this to n square. So here what we can do, so see here we are always, like every time we are calculating the sum, right? So this can be optimized. So here in this algorithm, what we are doing, we are first basically calculating all the lengths, right? And here we are optimized the way of calculating the sum for each and every subarray. So basically what we are doing here, first for example, three length array. So what we are doing, first we are calculating the sum of the first three elements. And here in this case, the first three elements would be 15 here, correct? And now what we are doing, every time when we are going for the next subarray, for three length subarray for example, so then we are removing this array, right? We are excluding this array and we are basically including the next array here. So that is what I am doing here, including the next element and we are excluding, right? I'm subtracting the last element here from the sum. So what I will do, from 15, 15 minus 15 plus the next element, that is minus 8, right? So here minus 8 here. So here this sum would be minus 8, right? And this is not 0. So what we will do, we are not basically including into the result here, right? And for the next element, then what we are doing here, for next, so now this is the last element, right? And this would be our next element. So we will exclude this one and we will include this one into the sum. So here minus 8, and we will exclude this one, so minus 2, correct? And then we will include the plus 1 right here. So it would be minus minus would be plus, and this one, so it would be minus 5 here, right? So sum would be minus 5. So now for the next element, so next we will include this one, right? And here this would be the last element because this was our array, right? So this would, so we will exclude this one. So minus 5 minus 2 and then plus 7 here. So it would be 0, right? Minus minus 7. So see here, this is making this sub array is making sum to 0, right? And that is what we are getting here. And here we will update our result with the length is 3, right? So this is the way we are calculating. We have optimized our solutions to order of n square. So here you can see we are using only two loops here, right? I have added the code for this one also, and you can take it. If you want the code, you can comment below the video. I'll provide my GitHub link, right? So now this is order of n square, and now we will optimize this one to order of n. So what we are doing, so earlier what we have discussed till now, we have discussed n cube, that is the brute force approach. Then we have optimized it to n square, where we have optimized the way of calculating the sum, right, for the subarray. And now we are optimizing it to the order of n, right? Here this is the prefix sum algorithm, so we will discuss this one. So here you can see, so here we are taking one variable, that is the max length, and it would be our result, right? And with this one we are using one unordered map, right? Why I am using unordered map? Because here in this case order does not matter. We are basically looking for the optimization where we can get the result in order of 1, right? So that is why we are using here unordered map. And here unordered map of integer and integer. So here first integer will denote the sum and the second will denote the index here. So let's discuss the order of n prefix sum algorithm here to solve our question here, right? So we have discussed order of n cube problem, brute force one. We have optimized that into order of n square, and now we are optimizing that order of n square to the order of n, right? And here we are using the prefix sum algorithm. So what we are doing here, we are taking one variable where we will store the result, right? And we are taking one here unordered map. So I have created unordered map here of integer and integer, right? So first integer will where first value key basically we will store as a sum, and the value will be as a index here, right? So what we are doing here, an initial value, right? MP of 0, the map of 0, I will say 1 here. See, so map of 0 is 1, right? So 0th index, what I will do, this is 0 1, right? So leave it 1. So 0th index, what I will do, I will put it minus 1 here, right? So key is 0 and here minus 1, right? And then sum is 0, and here integer I to n. So we will go from 0th index to 0 1 2 3 4 5 6 7, right? So 0th index to the last index. And here we, each time what we will do, we will add that element to the sum, right? So initially sum is 0, correct? So what we are doing, so here let's do the dry run here. So sum, that is 0, right? And here I is 0, right? So this 0th element will be added to the sum. So 0th element is 15, so sum would be 15 here, correct? and then what we will do, we will check this element, this sum into the array, into the map, right? So if it is there, then we will calculate the length, else we will insert this element with the index into the sum. So 15 is not here, right? So what we will do, key we will put 15 here, and index is 0, right? I is 0 for 15, correct? And then what we will do, then we will go for the next element here. So next we are going, that is -2, right? So we will add I is 1, and the sum would be here 13, because 15 plus -2, that is 13 here. So 13 is also not there, so what we will do, we will add this also into the map, and here index would be 1, right? And then next we will go for the next element here, I is 2, right? I is 2, and now the sum would be 15 again, right? Because 13 plus 2, that is 15. Now we see 15 is already there, right? So what we will do, we will take the max length, whatever the result we have, and the I minus MP of sum, right? So max length is having the length of the largest subarray, whatever we have encountered, which is having the sum 0, right? And here I is 2 minus MP of sum, right? So sum is 15. 15 is having at index 2, right? So 0, sorry, right? So basically what it is saying, at the 0th index we made 15 sum, right? And now again we are making the sum to 15, means after the last index we are making the sum is 0, right? We are not contributing anything basically, right? So here you can see, here after 0th index, see, sum of 15 is saying 0 index, means here till if we exclude this one, then we are making sum 0 with these two elements, right? After this, whatever we element we have. So here this is 2, right? So 2 minus 0, that is 2. So this is the length of the subarray which is making sum to 0. So this would be our result basically, max length, correct? And then we will go for the next element here. So next is this one, 3, right? Next is 3. 3 is -8. So here 15 15 plus -8, that is 7, right? And index is 3. So 7 we have add here 7, and index is 3, right? And then we will go for the next element here, 1. So we will add it 7 to 1, so it would be 8, right? And 8 is not there in the map, so we will add 8 and its index, that is 4, right? And then we will add the next element here, and that is 7. 7 and 8 would make 15 here again, right? And this index is 5, correct? So 15 is already there in the map, correct? Here 15, and the index is 0 for 15. So it means last time when index was 0, then that time we made sum to 15. So after that we are not adding anything, whatever we have added, that make sum to 0, right? So, and you can see the same thing here, right? Here after 15 index, that is 0th index, right? It is there in the map. And here after this one, if we do this one and the index is 5, correct? This one. So this is this sub array is making sum to 0, right? That is why after this, if we add 0 to this 15, then again it is making 15 only. It is not making any progress, right? So that is why now we can calculate the length here. Max length whatever we had, that is 2, right? That is 2, and here max length I is 5. So here 5 minus 0, basically 5. So here max length would be 5, right? Max of this one, correct? So here max length becomes 5 now this time, correct? And after this we are here at the 6th index, and this is 10. So here 15 plus 10, that is 25, and index is this is 25, and index is 6, right? We add one more place here, and here we add this one, 7, 23. So this would be 48 basically, right? 23 plus 25, and here just add 48, and index is 7, and we are out of the array, right? So now through all the array we have iterated only once this complete array, and we have calculated the max length is 5 here, right? This is our answer, correct? So I hope you understood this one. So this is the very important algorithms, this prefix sum. So here it can be used with other questions also, that we will be discussing in upcoming videos, right? So for this one I hope you understood. This is very simple. What we are doing, just we are iterating through all the complete array. Every time we are adding the that particular index value to the sum, we are using that sum as a key, and we are checking that key into the map. If it is there, then we are calculating the length. Else we are just inserting that value with the key into the map, basically unordered map, right? And an unordered map gives the result in order of 1. That is why, right, we are using the unordered map here. Correct. So the time complexity of this algorithm would be order of base n, right? So now let me show you the code here. I will like I have implemented this into the C++, so I'll show you the C++ code, and then we will run their multiple use cases. So this is our question here, and this is the algorithm brute force approach, right? It was taking an order of n cube. We have understood it, right? Here we are using 3 loops. Then I have optimized it to the order of n square, right? There we have optimized the way of calculating the sum. This is the code, and then this is our prefix sum algorithm. So where we are like solving this problem into the order of n time complexity, right? So here we are using unordered map, and here we have one loop for iterating all the through all the elements, right? And here we are adding into the sum each and every element, and then we are checking into the basically map, right? And if it is there, then we are calculating the max length, right? And then if it is not there, then we are inserting that sum with the key, that is the index, sorry, with the value, that is the index, into the map, right? And here we are returning the result. So I hope you understood it. Let me run it. So let's build it first. So yeah, build is fine. So now let me run it. It is asking for please enter input array size. So we have taken 8 size array, right? So let's take 8 here, and then we are putting the, it is asking for the elements. So 15 minus 2, 2 minus 8, 1, 7, 10, and 23. And here we have calculated length should be 5, right? Largest subarray. So see, largest subarray length is 5 in all the 3 cases, right? All the 3 cases, because I have like I am calculating all the 3, like using all the 3 methods here, right? A brute force one, then the optimized one, and then this prefix sum, right? Order of n. So all 3 are giving 5. So here let's try with the some other use case. So here size let's take 5, right? And here let's take 1 1 1 2 minus 5, right? Minus 1, this is 6. So these 5 elements, right? So here we can see 2, because these last 2 elements are making sum to 0, right? Others are not. That is why we are getting 2 here. Correct. So I hope you understood it. You can take this code from my GitHub account. You can comment below the video. I'll provide the link there. That's all from my side for today. I hope you understood it. Yeah, see you next time. Till then, keep learning and keep exploring.